Welcome to Operating Systems 2 lab tutorial video. This tutorial introduces how our lab sessions will be operated remotely and also will guide you how to set up the environment for JOS Lab. Let's start with logistics. We will deliver lab exercises remotely, so we will upload the lab tutorial video, which is around 30 minutes long at each week. The video and the slide give a guide on essential things that are necessary to finish lab assignment. So after watching the video and following the instructions in the video, you can start lab assignment exercises by your own by referring to the lab instructions on our course website. If you go to the website and then click on Lab 1 or like the lab setup page, the website will provide a step-by-step guideline for finishing each lab assignment with this kind of description and exercise. So the descriptions are written in detail regarding describing the goal, background, tasks, what to do, etc. So it's just following these kind of the instructions to build your own operating system for the lab assignment. But this lab assignment could be very difficult for you for some of you because it includes many system level details. For example, how can you supply data to CPU directly to work with them for controlling memory management, because CPU uses like a specific data structure, so we need to build that and use that as an operating system. So these kind of details are in the lab instructions, but if you are not familiar with those, then it could be difficult. Or it could require you to write many assembly code for some part of the operating system. So please start the lab assignment as early as possible. So and at least read the lab instructions, the descriptions for those kind of the exercise part, because it includes what you should do to estimate the difficulty of the lab. So you could have a better time budget plan if you read all the instructions for what you should implement first before really working on the project. So it depends on your background level, so please do so and estimate your time budget. But myself and TAs, will not leave you alone while you are struggling with many difficult tasks in the lab assignment. And to give you many help, we will open around 28.5 hours per week of office hours. So this calendar shows that our schedule for office hour and each job slot, write down who will be available, TAs and myself. Yeah. So please check the schedule on the calendar and feel free to ask questions to TAs or myself on Discord, or visit our Piazza to leave offline questions at there. Next is about JOS Labs. In this term, we will cover 4 JOS Labs from Lab 1 to Lab 4. And entirely, these lab projects will take 70% of your grade points. For example, Lab 1 is about booting, starting from BIOS to bootloader to kernel, and it will take 10% points. Lab 2 is about implementing virtual memory manager, and it will take 15% points. Lab 3 is about implementing user environment and system calls, will take 20% points. And Lab 4, which is implementing preemptive multitasking and inter-process communication, and it will take 25% points towards your grade. And there will be some extra credit labs within each labs. Each of extra credit labs will be 1% points, and you can see that as a challenge in each of a lab instruction webpage. And you don't have to finish all of that, and you can also decide whether to finish that or not while you're working on the labs. This is the end of the introduction to our lab assignments. And today we will go over 3 things for the tutorials. First is setting up the lab environments, and second, we will guide you to how to commit information to JOS repository, and finally, we will demonstrate how to run JOS with tmux. Next is about setting the lab environment. Please visit our course website, os.unexploitable.systems, and click Lab and Lab Setup. We will go over step by step to finish setting up the lab environment in our OS teaching servers, OS2, OS1, Old OS 1, Old OS 2. You can use either one of the server among these four. In this tutorial, we will use the server OS2, but you can use any kind of server available. Let's start with logging into the server. If you are using Linux macOS, just typing the SSH command with the username at host address will let you get on the server. If you are using Windows, you may use your preferred SSH client, such as MobileXterm or PuTTY, or you may install Windows Subsystem for Linux, which will give you the Linux-like console that you can use. To do that, please follow the instructions on the website, link that here. And let's copy the command line and then move to the console. To log in, paste the copy string and type your username. In this tutorial, I will use my test account, which is COE_Jang. Note that to get on our OS teaching servers, you need to be on OSU network. You can have that remotely by connecting to OSU VPN, or you can get on our Flip server first and then get onto OS2 or other servers from Flip. After typing the password, you will get the shell. Next is about running the setup script. Please copy the string in the box below and get back to the console. Paste it, and then it will fetch setup script from the GitHub server. And basically, it will set up GDB, tmux, bash, and vim. If you have your own .dot files and want to use that, then please answer no to each item, which is typing N to the console. Otherwise, if you don't know what's going on, what is .dot files, or would like to use our prepared environment, say yes to all, which is typing Y to the console. Then the script will set up the environment for you automatically. After finishing the setup, please log out by typing exit and enter, and then log in again. You will see the bash prompt changed one if you applied our script to your environment. Next is about creating an SSH key. If you already have your SSH key that you are using, then you don't need to create this, and you can use your public key for our GitLab. Otherwise, please create one by running the command ssh keygen. To do this, please copy the command line and paste it on the server console and type enter for several times. Doing this will create a public-private key pair. After that, you can print your public key by copying and pasting the command below. Please copy the string because we will register this public key to our GitLab server. Next is registering a GitLab account. We will use a private GitLab server to store all your lab assignment work. Note that this GitLab runs in-house at OSU and is a different one with the regular GitLab, which can be accessible by gitlab.com. So you will need an account if you have not used it before, and to do that, please visit the website gitlab.unexploitable.systems linked on the web page. For the registration, please type your real name and preferred username and add oregonstate.edu email address and password. Note that this server is only for OSU students, so it will only accept at oregonstate.edu email address. For those who would like to check our terms of service, I put a note about the FERPA Act, which is for protecting the privacy for your educational record. Basically, the server is running within OSU and all the data will be remaining in OSU too. After clicking the register button, it will ask you to click a link in the confirmation email. If you have not got the email, please check your spam folder or click the button again to get the message once more. After that, please log on to GitLab. For the next, we will register your SSH key to GitLab. To do that, please find the settings menu on the top right corner of your GitLab. Click the icon at the top right and click Settings, and then click SSH Keys. If you cannot see the menu SSH Keys, you can enlarge your browser screen a little bit, then you can see the text. And then copy your SSH public key from the console and paste it on the web browser. And then click Add Key. By doing so, now you can access this GitLab with your private key. Next step is about forking the lab repository. We have prepared the central repository, and you will create your own repository by forking from the central one. To do that, please click the repository link in the page first. Now at the URL bar, you can see the username root, indicating that this repository is owned by the administrator root. To create yours, on the right side, there is a button named Fork. Please click that and click your name to fork the repository to your own namespace. Then, now you can see your username at the URL bar. This means the repository is now forked and now it is yours. All your works should be committed and pushed into this repository. Our TAs will use the code in your repository to grade your work. And in this GitLab, you may browse all your code in the web interface. This also allows you to edit some files, but please do not do that for now. We will practice commit and push, and we'll do that for the student.info file in your repository root. Before moving to next, please change your repository permission from internal to private. The permission internal means that anyone on the server can read the repository. To make your repository hidden from other students, please go to the repository settings and visibility and others, and then change the visibility from internal to private. After making changes, you will see that your repository is now private repository. To work with your JOS repository, let's clone the repo. You can get the clone link by clicking the blue clone button and copy the string at the clone with SSH. To move to next, let's clone the repo from the server. You can do this by typing git clone and then paste the link address. After that, you can get into the JOS directory. The prompt shows that you are in JOS directory and at lab1 branch of Git, and you can also see the list of files. To check if the lab environment setup is done correctly, please run make qemu nox. This will boot JOS using QEMU emulator and print out all the messages from JAWS to the console. You will be okay if you see the same output with the output shown on the video. And running JAWS make us stuck in QEMU, so you cannot get back to the console because there is no exit menu at all. And to exit from QEMU, please follow the guideline. Type Ctrl A and then X. Then the command will kill the running QEMU and you can get back to the console. Right now, we did not implement anything about the lab, but once you finish implementing part of the lab 1, you can grade your code by yourself. To do that, run make grade. Now it shows a bunch of fails and your score as 0/50, but within 2 weeks, you will finish the lab and will get 50/50. Of course, once you get it done correctly, you will see the green OK sign for each item. Next is about step 2, editing student.info. You can open the file with your preferred editor, and in this tutorial, we will use Vim. After opening the file, please type in your OSUID, the 9-digit number, and then ONID username, which is the server username. And then type your name and indicate either you are in CS444 or 544. And then write down your registered lab session number. To help with that numbering, lab 1 is starting at Tuesday at 10. Lab 2 is for Tuesday at 12. And lab 3 for the lab that is on Wednesday. And lab 4 is for the Thursday one. And lab 5 is for the Friday one. And the reason why we would like to collect this kind of information is to match your GitLab repository to your OSU account for grading purpose. After finishing editing, save the file and run git status. Now you can see that your student.info file is edited from the status. To commit your change, you can add the file via git add, and then you can run git commit to commit it. There could be some error message if the editor for Git is not configured well. To fix that, just quit the Vim without saving the commit message, meaning like quitting with the Q, not the WQ. And then please run commands to set up your Git environment. So you can copy and paste like 4 different commands from the website to the console. For example, you can set your email address for a commit message. You can set your name, and you can also set your editor, and you can also set your merge strategy. If you do not have preference, please apply the commands on the website. Otherwise, you can apply your own setup. Yeah. And then let's run git commit. You can write a commit message and save, then your commit is finished. But committing in Git means that it is stored locally, not on the server remotely. To make your change available in the repository server, please run git push. After your push is successful, let's get back to the course GitLab website. Now you can see the commit and also can see that your student.info file has been updated. Finally, we will practice how we can work with JAWS conveniently with tmux. tmux is a terminal multiplexer that allows us to create multiple windows and panes in a terminal. In other words, we can split the terminal into multiple console screens. For example, we can split the terminal vertically, and we can also split the terminal horizontally and run commands in each console screen. And then let me introduce how you can control split the terminal in tmux. With the setup with our configuration, the control sequence is backtick, a key which is right next to the key for number 1. And to split the screen vertically, you can do it by typing backtick and %, which is Shift and 5. To split the screen horizontally, you can type backtick and double quote, which is Shift and quote. Additionally, to create a window, you can type a backtick and C for create, and to move to a different window, you can type backtick and the window number. For example, window 0, window 1, something like that. And moreover, to move around panes, you can type backtick left arrow to move left, right arrow to move right, and upper arrow to move to the upper pane, and get down with the like a backtick and down arrow. So backtick and the arrow to move the cursor position. Now let's run both JAWS and the GDB debugger at the same time using tmux. Let's split the screen vertically with backtick and %, and then on the left side, backtick left, run make qemu_nox gdb. This command will make JAWS wait until our debugger attaches to it. And then move to the right pane by pressing backtick and right window and run gdb. Then now you can see the execution starting from the BIOS. During finishing Lab 1, you can set a breakpoint to the bootloader, which is 0x7c00, and do continue. And you can also set a breakpoint to the function, for example, i386 init, and continue. And then you can monitor how the kernel executes with output, disassembly, source code, and the program stack matched with the execution at the same time. As the final remark, I would like to introduce a feature that you can share your tmux screen with a TA to get help by working on the same code together. You can regard the terminal on the left side with black background as the terminal owned by a student, and the terminal with the white background as the terminal operated by one of our TA. To get TA help, you can type TA-help on your command line. This will print out some text, and please copy the part after the colon with something with TMP and OS2. And then send that string to the TA via Discord. And then you press enter. You will get into a regular tmux session. On the other hand, after TA gets the string, they can connect to your tmux session. For example, when they get on your session, they can also see what you are seeing on the screen. Also, they can also type, and you two will share the same terminal. To get help, you can browse the code and ask directly in the editor and get help from your TA. Hope this will help you, and please work hard for Lab 1.